All right, so we are now in problem 2.1 and question 4. Question 4. In question 4, we want to determine whether these two functions are equal. Want to determine whether these two functions are equal. Okay. The first one is our f of x, which is s squared minus 4x plus 3 all over x minus 3 if x is not equal to 3. And then we have 2 if x is equal to 3. That is f of x. Then another function we have there is g of x, which is x minus 1. Okay, so we want to determine whether these two functions are equal. The first thing to check if two functions are equal is the domain. So we need to find the domain of f of x and then find the domain of g of x. If the domain are not equal, then automatically we stop and conclude they are not equal. But if the domain are equal, then we'll go to the next step and check each x. When you put each x in f of x, the output, is it the same when you put it in g of x? So if we are able to confirm that, then they are equal. Okay, so let's go for the domain first. Domain of f of x. Domain of f of x. Okay, domain of f of x. Let's look at f of x. This value, f of x is a piecewise function, is a case-defined function. So for the upper one, the domain is everywhere except at what? X equals to what? 3. Okay, so the domain of the upper one is minus infinity to 3 union 3 positive infinity. That is the domain of the upper one. The domain of the lower one is just s as 3. Okay, so if we combine these two together, what is the domain of f of x? Because this one is not defined as 3, but this one is defined as 3. So the domain of f of x is negative infinity to positive infinity, the whole of real number. That is the domain of f of x. All right, so let's find the domain of g of x. Domain of g of x. Of course, in g of x, we don't have any restriction there. So the domain of g of x is also the whole of real number. Okay, so the first condition done. That means the domain are the same. All right, so we go to the next one. Condition 1. Condition 2, we want to check each x. So if I pick x equals to 1, x equals to 1 in f of x, it will fall here. X equals to 1 in f of x will fall here. So if I put 1 here, I'm going to have 1 squared minus 4 plus 3 over minus 2. And the answer of that will give us 0. Okay, so if I put 1 in f of x, I will get 0. Now let me put 1 in g of x. I put 1 in g of x, I will also get 0. Okay, that is fine. Let's put 3. If I put 3 in f of x, I'm picking this one because this is this case where x equals to 3. If I put 3 in f of x, I'm getting 2. Okay, let me put 3 in g of x. What I will get is still 2. Am I right? Yeah. So now again, let me pick another number and then I conclude. Let me pick 0. If I pick 0 in f of x, I will fall into this place. So this will be 0, this will be 0, 0, 3 over minus 3, which is negative 1. Okay, if I pick 0 here and I put 0 in g of x, I'm also going to get negative 1. So you see, for every x put into f of x and put into g of x, I'm getting the same output. Because of that, I can conclude to say f of x is equals to g of x because the two conditions are satisfied. So I can say f of x is equals to g of x. Okay, that is fine. Example 2. I want to find the domain of h of x when it is equal to x minus 2 over x plus 1. Okay, I want to find this domain. Okay, in finding the domain, okay, there's another video also about this domain of Ruth. So make sure you check that out. Okay, but in finding the domain of these, don't forget, whatever we have under the Ruth cannot be equals to negative, cannot be negative. So that means the whole of these must not be negative. So that means x minus 2 over x plus 1 should be greater or equals to 0. Should be greater or equals to 0. All right. So if you want to solve that, you multiply both sides by what is at the denominator. Then you are going to get x minus 2 greater or equals to 0. Then you have x greater or equals to 2. So we have this part, which is from 2 to positive infinity. But don't forget we have a denominator. And we mentioned that anytime we have a denominator, the denominator must not be 0. So, in the real sense, if not because this is under the square root, if I'm giving a function like this, let's say I'm giving a function g of x equals to x minus 2 over x plus 1, if this is what I'm giving, in the real sense, I will be looking for where this is not 0. That means I will be looking for where x plus 1 is not equals to 0. And the domain of this g of x will now become where x is not equals to negative 1. That means the domain of that will be negative infinity to negative 1 union negative 1 to positive infinity. So that will be the domain of this. So now we are considering where it is under the root. So that shows that this other second part is now replaced with this other one because of the root. Okay, so the domain of this function, under the root is now, the domain of that function is now negative infinity to negative 1 union 2 to positive infinity. That will be the domain of that function because of the root that is there.